Hey everyone, my name is Nick Brooks, and today I'll be explaining the difference between cold fronts and warm fronts and how they affect aviation. We will also be discussing how to identify them on a weather forecast, as well as what kind of weather anomalies they will cause depending on how they meet in the sky. The reason they're called fronts to begin with is that when the Norwegian meteorologists in World War I were watching the warm and cold air masses crash together, they compared it to when two armies meet, creating a battle front. And when this happens, it is a very brutal occurrence, in which it is a pretty accurate representation of what happens when these two air masses actually meet. Now, an air mass is a large body of air that takes on the same characteristics as its surrounding area. They can form over cold, dry, polar areas, warm, moist, tropical areas, and even scorching hot desert regions. In total, there are 4 types of fronts: warm fronts, cold fronts, stationary fronts, and included fronts. When a warmer, moist air mass pushes into a colder, drier air mass, this is called a warm front. When a warm front is occurring, the warm air is pushed up at a slight angle, causing a large area of precipitation and overcast. Warm fronts can be identified by a red line with red half circles pointing in the direction in which it's traveling. Warm fronts produce high-altitude clouds like cirrus and cirrostratus, and middle clouds like altostratus. A cold front is almost the opposite. A cold front happens when a mass of cold air wedges itself underneath an approaching warm air mass. When this happens, it can cause very extreme weather conditions, such as cumulonimbus clouds, which can produce heavy showers, hail, and even thunder and lightning. A cold front can be identified by a blue line with blue triangles pointing in the direction that it's traveling. Cumulonimbus clouds are very hazardous to small aircraft and should very much be avoided. They form in 3 stages: the developing stage, mature stage, and the dissipating stage. The developing stage consists of a cumulus cloud being pushed upward by updrafts. Not much rain occurs at this stage, but there can be some lightning. When it arrives at the maturing stage, it really becomes a thunderstorm. Updrafts continue to lift the clouds into an anvil top, as downdrafts feed rain-cooled air out of the bottom, creating hail, rain, sleet, and other bad weather conditions. After some time, a large amount of precipitation will force any remaining updrafts downwards, thus causing the dissipating stage. At this point, the rain will begin letting up, but lightning is still a real danger. There are 2 more types of fronts: stationary fronts and included fronts. A stationary front occurs when a cold and warm air mass create a dividing line between themselves without protruding into each other. When this type of front ensues, it can cause lots of widespread precipitation, similar to a warm front, but can last a substantially longer time, as much as a week. A stationary front can easily be identified by the alternating blue triangles and red half circles pointing into each other. And then last but not least, there's the occluded front. This specific front happens when a faster cold air mass is overtaking a warm front. The faster air mass wedges itself underneath the warm air mass and subsequently forces the warm air mass upwards off of the ground. Because an occluded front is basically the combination of a warm and cold front, the weather conditions produced are somewhat of a mix of the two, with widespread precipitation, as well as thunderstorms and other active weather. It can be identified by a purple line with alternating triangles and half circles facing in the direction that it's traveling. I hope you all enjoyed the video and learned a thing or two, and I wish you all a great rest of the day. Thank you.